Hello students, this is the second lecture of set theory. Now we have already studied about the basic terminology of set theory and the how to use this set theory. Now more terminology are there. In this lecture we are going to study about like subset, what is the subset, what is the like how to equate two sets, and in algebra we know that when we have to add the number and we have to subtract the number, we have the principle, right? Addition and subtraction principle. So in set theory, if we have to add two sets or subtract two sets or negate the sets, so how we have to use the addition and subtraction of the sets, like, so that we'll understand in this lecture. And that's very important lecture. At least one question you will get in your competitive exam as well as in your board exams through this lecture. So let's enjoy this lecture and go through this.
Right now, subset. If all the elements of set A, now we understand what is set, right? All the elements of set A is also element of set, let's say T, then S is the subset of T. See, S is 2, 4, 6, T is 1, 2, 3, 4, 5, 6, 7. So if you'll go with a, like you can say the diagram is there, S and T, right? This T is there that contain the element 1, 2, 3, 4, 5, 6, and S is inside this. So S is a subset of T. Represented by this, you have to remember this notation. S is a subset of T. This is the notation that you have to remember, right? Or 2, 4, 6 is a subset of 1, 2, 3, 4, 5, 6, right? But in the same manner, if I'm saying S is not the subset, so first you have to write down the subset and then cross it. Then this is S is not the subset of T. Example, you can understand if any one element is not there, 1, 2, 3, 4, 5, 6, 7, 8 is not there, so S is, in this case, S is not a subset of T. It's only the notation part, and obviously you can understand very easily these things. Right now, you have to remember few things about subsets. Any set is a subset of itself. Like any set, I'm saying, like S is equal to 1 to 3. Since all the element of S are in element of S only, so this S will be the subset of S only, right? So 2 is less than or equal to 2 is always possible, right? So you can remember this as we are writing this something as less than or equal to. This S is less than equal to S only if S is maybe less than or equal to, right? For remembering this thing, this will be easier for you, right? Now the next thing you have to remember, empty set is always subset of all the sets, right, including itself, right? Empty set, nothing is there, right? Phi or null set is always a subset of all the elements, right? Nothingness is always there, right? And if I'm saying the universal set, everything what we can think, everything is there, is called the universal set. In this universal set, there would be a subset, right? Everything will be the subset of this universal set. Everything lies inside the universal set, right? Now, how to represent this? What is the formula for this, right? This is the notation for all. This you have to read as for all values of x, right? For all values of x, x belongs to A. That implies, this is the sign of implies, that x belongs to B. If x belongs to A, if x is the element of set A, that implies that x is the element of B only. This is the mathematical expression you can represent subset, right? So in a one line, how you read this? For all values of x, right? All values of x, if X is the element of A, then X is the element of B. Okay. So notation, we have to be very particular ki exactly what mathematics is saying. That's the reason the set theory, that is called the language of mathematics. Like you first we have to understand ki what language they are saying, then we can proceed with that. Right? With the subset, right? One more thing we have to understand as the proper subset. Right? S is the subset of T. Obviously, now we know that element of each and every element of S must be in T, right? And S is not equal to T, right? As we said, that S is a subset of T, so this may be equal to or less than. So in this case, we are saying that S is a subset, but not equal to. Equality sign is not there. Then S is known as proper subset of T, right? Like if with the example we can understand easily this thing. T, I'm saying 0, 1, 2, 3, 4, 5, 5 elements are there, right? And in S, only 3 elements I'm taking, or 2 element or 1 element I'm taking. Like in this example, this is 1, 2, 3. So S is not equal to T, but each and every elements of S lies inside T. So this is known as proper subset and represented by without equality sign. X is a proper subset of T, right? Number 1 belongs to S as well as T. Number 2 belongs to S and T. Number 3 belongs to S and T, but 0 belongs to T but not S, right? One more example we are taking there is R is equal to 0, 1, 2, 3, 4, 5, right? So in this case, R is equal to T, right? Each and every elements in R and T are same, so both are equal sets, right? So this about the subset, this subset is not a proper subset, right? We can write this, but we can't write proper subset. So now again, if this is not so, write down and cut it down, then meaning of this is not a proper subset, right? Okay, now what is the difference between subset and proper subset? I guess you all understand. It's a difference is less than or equal to, right? If you are saying less than, means you are going for proper subset. If you are going less than and equal to, you are going for subset, right? Both the terminologies are different, so we have to like understand accordingly. But Venn diagram is one of the best way to understand what we are saying. See this thing. Let this is S, this is R. R is bigger than S. So all the elements of S, all the elements of S is lying inside R. So S is proper subset of R, right? But let's suppose if I'm saying one example, this, and this is S as well as R. Both are now cardinality of the sets. Cardinal means the numbers, right? Number of elements in the sets, usually denoted by A and two vertical lines, right? R 1, 2, 3, 4, 5. So number of elements in this will be 5, right? Null set 5, no elements, so we are writing 0, right? In this, S is phi A B A B. Don't confuse with this, right? This is number 1, 2, 3, and these complete one thing, so 4, right? We are counting phi as a one number, A as a one number, B as a one number, and we are getting AB as one number. So total number of element or cardinality of this will be 4, right? And obviously, if you have used this thing vectors, right, mod notation, this is called mod notation or the length notation. So this A we are representing as modulus is the vector notation for the length, right? Or in a complex number, this is called mod, or in a algebraic mathematics, this is known as modulus, right? And this is for, in the set theory, this is known as cardinality, right? So one thing we can go for different notations, right? Or different names for different topics. A set with only one element is known as singleton set. Singleton means single, number one only. Power set. What is the meaning of this power set? We are taking an example as S is equal to 0 and 1. What are the possible सबसेट ऑफ एस? क्या क्या एलिमेंट्स पॉसिबल हो पाएंगे? सो वी नो दैट फर्स्ट एलिमेंट विल बी ऑलवेज अ नल सेट, right? Already we have studied this, right? Then we can take singleton set as 0 or 1 and the complete set as 0 1. So how many elements we are getting in this case? In this case we are getting 4 elements, right? The total number of subset of S will be 4. We can write down S in 4 different ways, subsets. So this is known as power set, usually denoted by PS, power of set S, right? So power set is 5 null set, 0, 1 and 0, 1. 4 elements are there. S is equal to 2, PS is equal to 4. 4, that is 2 square, right? Like I'm saying 0, 1, 2. Now look, how many possible cases are there? One, first will be always the null set. So we are taking 5 as a null set. Now 0, 1, 2, right? Singleton set and taken 2 at a time and then taken 3 at a time, right? So null set taken 1 at a time, taken 2 at a time and taken all at a time. So total number of elements in this case will be 8, right? For null set this will be obviously 5, only one element is there, right? For n elements we have formula for this is 2 to the power n, right? Tuplets. In two-dimensional space, like in xy, if you are representing this in x and y coordinate, x-axis and y-axis, this is known as x-axis and y-axis. So in two-dimensional or three-dimensional or four-dimensional, anywhere like this, if I'm saying this is x-axis and this is y-axis and we have to represent a point 2 comma 3, right? This 2 comma 3 is representing here only, right? Means its distance from x-axis is 2 and distance from y-axis is 3. This is known as 2 comma 3. In 3 dimension we know that there will be 3-dimensional space at 1, 2 and 3, right? But we know that both the numbers, if I am writing 1, 2 and 3 and 3, 2, 1 will not be same in 3 dimension, as if I am giving you 2 comma 3 and giving you 3 comma 2, both the numbers are different, both the numbers are not same, right? So in 2-dimensional space or in n-dimensional space, that's called n tuples of numbers, right? So this is known as tuplets. 2-dimensional tuplets, 3-dimensional triplets, n-dimensional, this is called n-tuples, right? And this is known as ordered pair, right? Like अभी तक जो भी हमने पढ़ा सेट में वी सेट कि like 1 2 3 4 the numbers are in the set and 5 4 3 2 1 is in the set, both are same, right? But in the ordered pair, if you are writing 2 comma 3 or you are writing 3 comma 2, both the numbers are not same in ordered pair, because x is 2 in first case, x is 2, y is 3 in second case, x is 3 and y is 2, both are not same, right? This is called ordered pair. X comes first, y second, and in 3-dimensional z third, right? So this will start a new topic for you, that's called the Cartesian product, right? Cartesian product may be for order 2, maybe this could be for order 3, 4, 5 and n things, right? It's usually denoted by A cross B, right? A, this is read as A cross B. So in 2-dimensional we are saying integer cross integer, right? Z represent the integer, so integer cross integer. So we can draw the lattice. Lattice is called when we are drawing the x-axis and y-axis and representing each and every numbers are there, right? So this is known as lattice. Lattice. All the product 1 comma 1, 2 comma 2, 3 comma 3 all are there, right? So what is the meaning of this Cartesian product? A is given, B is given. Then Cartesian product A cross B is A0, A1, B0, B1. In the set we can write this is A cross B, right? B cross A will be different because we know that A comma B is not equal to B comma A in ordered pair unless A is equal to B is given, right? A is equal to B अगर मेरे पास given है तो obviously both will be same. So Cartesian product, right? If I'm writing A cross B, A comma B means A represent A belongs to the set A and B belongs to the set B, right? So this is written as A comma B means you have to understand the first element goes for A and second element goes for B only, right? A is 1 2, B is AB, right? So if I'll multiply A cross B, so first element 1A, 1B, 2A, 2B, right? Set A, M elements, set B, N elements, right? If I'm saying set A contains N elements and set B contains N elements, then A cross B contain Mn element, M into N element. You can see with the examples also, right? This is very important formula. We have to use this. So remember this formula. Cartesian product for 3, if we are taking this, for AB, A belongs to and B belongs to B only, right? One example, if it is given in the set form, right? Set S contains Ali, Bob, and Chintu, and G. Set G contain A, B, and C. If you are multiplying this, right, you are going with S cross G, right? So every element of set A multiply with 1, 2, 3, and then Bob will go with ABC, then Chintu will go with A, B, and C. So Cartesian product, right? The finally we will get each and every elements there. Like this complete elements are 1, 2, 3, 4, 5, 6, right? Or you can say 3 into 3 will be 9. Total elements will be 9 there, right? And subset from this we are writing. So three subsets. These three are the subsets of the given. We can say this is the universal set for this, right? So can you think how many elements will be there, right? How many relation will be there, right? That's very important thing. How many ways we can write the things and how many numbers would be there, right? With the example we can go. A is 1 2 3 and B is A comma B. So what is A cross B? Just directly you can go with the answer. How many elements are there? There must be 3 into 6 elements. They don't have all the elements. So 1 2 3 4 5 6, only D option giving you the 6 elements, and you can see the numbers also. Set operation. Now when we have to add two sets, subtract two sets, so we have to go with a new terminology. For that, to understand the addition subtraction of the sets, we are going to take a primary color segment that's known as a triangular gamut, that is called the color range of this. So first triangle we are making for that gamut. For first triangle it is the monitor color gamut and the second is printer color gamut. And now when we have to add or subtract in set theory, we are going to understand with the help of this color segment how to add or subtract. So first terminology is called union. Union of the set means it contains all the elements in either set. Means this is the person, this is the person, there, this, and this is the person, and this segment, the common one, also we have to take. So in figure we can say these all person will be the answer. Usually this union is denoted by U for this case. Already we have seen this U for universal set, but that was different. For addition or for union of element, we always write this as M union P. That is the whole segment, and the common segment is also coming into this. To understand this in easiest way, the best way is a Venn diagram. If we are drawing the Venn diagram, so this is a universal set. This is the set A and set B, right? We have to write down A union B, means this is the person, this is the person, and the common person. So the complete person A, B, and the common person in between is known as A union B, right? So few operations are there and few properties are there on this operation. So let's start with this. A union null set. Phi is a null set. So again we'll get A, means you are adding A with null set. So again we are getting A. This is known as identity law. If I'm adding this A with complete union, is submerge on union. So this is the altogether you are getting U only. This is known as domination law. And the idempotent law is well-known law. This is A union A, means you have to take A only, and again A is on this only. So A union A is A only. You are adding A with A, only the common portion, that A will be there, right? Commutative law, A union B or B union A are same. Associative law, you know that if you are adding A plus B plus C, first you are adding B plus C, then going for A, or you are going for A plus B first and going for second, then the second operation is with C, both the answer will be always same, right? So these are the operations for union denoted by U only, right? The same thing we have to understand for intersection. Intersection means the common person only. So you can see the monitor gamut of M and printer gamut of P, the common person you are getting in between, something like this, right? So if you need the intersection, so only the portion, the common to both will be your answer, right? The symbol for intersection is just reverse of the union one. That's reverse of U is known as intersection. And between 2M and P, the operation intersection is applied. So you can write in this way, right? But again, graphical way we can understand better. So Venn diagram for set operation for intersection A intersection B. So only the portion where both are common. This is known as A intersection B. Again, operation with this. So few of the basic operations. If I'm taking this as universal set U and let this is A, right? So A intersection U is A only, right? A intersection U. The common to U and A will be A only. We need common to A and null set. So obviously the null set is common portion for both of this. But when I'm going for A intersection with A, the common portion is A only, right? If commutative law, you know that A intersection B or B intersection A, right? Two sets are given. You are going from A to B or B to A, both are same. And same with the law. First, you are taking intersection of B and C, or you are taking intersection of A and B. Both you are getting the same answers. Okay.